In this video, we're going to be taking a look at the ProLogix Sensor Simulator Probe. We'll have a look at the different features it's got and how they can help you diagnose sensor faults on engine management systems. So inside the box, we've got the probe itself with the power supply cable and the remote ground lead on there as well. We have a crocodile alligator clip and then a smaller remote crocodile alligator clip there, and we get the probe itself. So the probe just fixes straight into the top of the unit like that. The great thing about these fixings are they are 4mm banana style connectors, so you can also use the ProLogix sensor test lead kit. The sensor simulator probe comes with many useful features for diagnosing sensor circuits. So what it can do is supply a reference voltage, so a sensor supply voltage up to 7 volts. And this can be activated in either 150 milliamp mode or 3 amp mode, depending on whether you are testing a signal circuit or a sensor power supply. It's compatible with 12 and 24 volt circuits. When it comes to sensor simulation, it has an ohm setting, so it can vary the resistance of the unit to test things like coolant temperature sensors. It has a frequency setting where it can output either an AC sine wave or a square wave digital signal. For the digital square wave signal, you can also choose whether it was positive or negatively switched. That would be depending on whether it was a pull-up or pull-down resistor inside the control module. What we also have is a PWM sensor simulator. This will allow us to replicate duty cycle signals for things like intake air temperature sensors on combined mass airflow and temperature sensors. So let me show you some of the features. To power the module on, simply connect the positive and negative leads to the battery. One of the great features about this tool is that it comes with a light function, so a torch on the front that can be turned on and off at the click of a button. So first of all, we're going to look at the volt setting. So this is for simulating reference voltages. We can test the voltage like a voltmeter. So if we go onto the voltmeter mode there, it works just like a normal voltmeter would. There you can see we've just gone on the battery voltage there, reading around 13.4 volts. And if we just exit out there, we can then go to simulate voltage. So it's just bringing up a warning there to make sure that you check the wiring diagram and make sure that you don't damage the unit by putting the wrong polarity down any wires. And here we can select either a 3 amp or 150 milliamp setting. Use the 3 amp setting for power supply on sensors. Use the 150 milliamp setting for things like voltage signals, so analog signal voltages. So we're going to test it out on a sensor power supply. So we'll just click OK there. And what we're going to do is ramp it up to 5 volts. Okay, we're ready to go. So we've got these breakout leads currently connected to this camshaft position sensor, and what we've got connected is the sensor ground and the sensor signal. We have disconnected the sensor power supply. It's a 5 volt reference power supply on this sensor. And what we can see here is we've got a fault code for the inlet camshaft sensor. So what we're going to do is use our 5 volt power supply that's currently coming out of the sensor simulator probe and feed that into the camshaft sensor. So now the sensor simulator probe is sending a 5 volt power supply to the sensor. Now what we can do is delete the code and cycle the ignition a few times. If this has solved the problem, then the fault code shouldn't return. Okay, so we've cycled the ignition now. Let's just erase the code. And if we read the code again, we can see that that's gone now. So that sensor probe is now supplying the sensor, and what we can do is follow that supply back on the loom to try and find out where the break might be, or even confirm that there's a faulty control module. The next feature we're going to look at is the frequency setting. So when we go onto the frequency setting, we are asked if we want to see a AC sine wave type signal or a digital square wave signal. To increase the frequency of the sine wave signal, simply click on the arrow buttons here. You can press and hold your finger on the button to scan through the frequency much faster. This is what the signal looks like on an oscilloscope. So this is the AC sine wave signal. As we increase the frequency, they will get much closer together. Reduce the frequency, they become further apart. So we could use this on something like a inductive type wheel speed sensor or a inductive type crankshaft sensor. If we exit out of the sine wave signal, we can now go to the square wave signal, and we can choose positive or negative volt. That would be depending on whether you had a pull up or pull down resistor inside the control module. And we can choose between 0 to 7 volts or 7 to 12 volt signal. So this car has a 12 volt signal on the crankshaft sensor, which is what we're going to try it out on in a moment. So now what we get is two options. We can adjust the voltage and we can adjust the frequency. So by pressing the up and down buttons, we can change the voltage in 0.1 increments. If we press the left and right buttons, we can increase and decrease the frequency. And this is what it looks like on the oscilloscope. So if we increase the voltage, you can see that the peak voltage increases up to 12 volts maximum. And if we increase the frequency, we get more pulses on the screen. So now we're going to use it to test the crankshaft sensor signal on this car. I've used the wiring diagram to find the crankshaft sensor signal wire in the ECU. That's the easiest way to access it. And I'm using the sensor test kit with some 4mm banana probes and back probes to get into that signal there. Okay, so we've got the live data showing up on the scan tool now, and what we can do is increase the frequency of that signal, and we should see the engine speed is starting to increase. We've got 13 RPM, 14. And what you might find is if you increase it too far with just the ignition on, it will register a fault and cut the line off. But you can see there, look, we've got it up to 795 RPM, and that's at 794 Hertz. So a bit of a correlation there, and now look, it's cut off, so it's obviously detected that the engine isn't actually turned on and we're getting a crank signal. What we can also see here is the RPM increases with that signal input, so that's a nice way to test the RPM signal. Okay, so the next feature we're going to take a look at is the variable resistance setting. We're going to set it up on the intake air temperature sensor and monitor it on the scan tool here. I've used the wiring diagram to identify the sensor ground and the intake air temperature signal. Okay, so I've disconnected the connector for the intake air temperature and pressure sensor down here, the MAP sensor. It has the intake air temperature sensor combined. It's a 4-wire sensor, so it shares the ground. So one of these wires is going to the ground and the other wire is going to the temperature signal. What we're going to do is connect up one of the leads to the output of the sensor simulator probe, and the other lead will have to go to this remote ground lead here. Okay, so connect one side up to here and the other one up to there. So now this is acting as the intake air temperature sensor. Okay, so from the main menu we need to go to ohms and select the range that you want. So we've got 100 to 1000, 1000 to 10,000, 10,000 to 20,000. We're going to go for the 1 to 10,000 as generally these NTC type sensors are in the range of around 3,000 ohms. So let's select that there and we'll take a look at the live data. So here we've got the intake air temperature here. It's currently showing 45 degrees. If I just disconnect the probe a minute, you can see that it goes to a default setting and it's stopped there at minus 17 degrees centigrade. So let's connect that up at 1000 ohms and you can see there that it climbs up to around 40 degrees centigrade. Okay, so that's 1000 ohms. If we now increase that resistance, we can now see the temperature value dropping. So if we go to the 3000 ohms, that gives us a reading of around 15 degrees centigrade. We can then increase it further and that temperature drops. Okay, so reduce the resistance, the temperature increases. A nice way to test your temperature sensors. So the ohm setting on the sensor simulator probe can be used to simulate any type of temperature sensor. It can also be used to simulate other resistance-based sensors like potentiometers. So it's really quite a versatile tool that lets you test various aspects of sensor circuits.